Okay, so this is a third problem of question about the formal charges. So let's look at that. So the first one is the compound shown up here, and we have to go by formal charges one by one. And if you have a compound looks like that, the formal charge is 0. If you have a compound looks like that, formal charge is -1. If you have a compound looks like that, the formal charge is 0. So then here I'm going to explain it to you once more. So if you look at the oxygen with this, the formal charges is number of valence electron for oxygen, which is 6, minus number of lone pair electron, 4, and half of number of bonded electron, which is 4, then makes it 6 minus 6, so that's a 0. So it's important to understand that's what you have. And the second useful, so this is one of the unit. The second useful unit for you to remember is this. This is a quite frequent here. So oxygen, once again here, that means 6 valence shell electrons right there. So the oxygen with 1 bond with 3 lone pairs, formal charges, 6 minus 6 plus 2, 2, 2. So that's 6 minus 7, that's -1. So it's good to remember once more, if you have some subunit structures, so oxygen looks like that, they can have either one of them. And that's very important for you to decide what kind of resonance structure you will eventually have. And the next one that is very useful here is something like a halogen, fluorine, bromine. Okay, so I'm talking about those halogens, chlorines, and bromines here. And if they are the halogens, and then naturally to satisfy the octet rule, you're going to make sure they have 3 lone pairs, 6 lone pair electrons following that. And because this is a halogen, the formal charges is 7 minus 6 lone pair electrons and half of bonded electron, which is 2. That's a 7 minus 7, which is 0. So these are the all formal charges is 0, and that's what this one is about. Okay, so once I finish that, there is a way that the remaining one is this, and this is one of the rule that I also like to use is formal charges of molecule is summation of formal charges of atoms here, right? So the formal charge of the molecule here is a 0, so therefore this must be a formal charges of 1. So that could be a one shortcut way to do it. And one way to follow the rule is nitrogen. So formal charges is nitrogen is here, so that's a 5. So 5 minus lone pair electron, there's none. Half of bonded electron, there are 4 bonds, so 8 electrons. So 5 minus 4 is +1. So I confirm my answer that this is a +1. Okay, so moving on to the second set of the question. So once more, this is quick. Okay, this is a -1. This is 0. This is 0. This is 0. And then overall, I know it is a 0 because no charge is being given. So therefore, the one inside must be +1, so that all the formal charges in all the atoms in here must be summed to the formal charges of molecule, which is a 0 here. And once again, I think that this equation is the same equation as here. 5 minus no lone pairs, 4 bonds, so formal charges of 1, and the answer is shown up there. Okay, final one is this. This is once again, okay, that's a 0. That is a 0. This is a -1. This is a -1. Okay, and then what do you have? This is overall is 0. It doesn't say anything. So therefore, this gotta be plus 2. Okay, so that's what I can see. But at the same time, I can do the rigorous math just like that. 4 more charges. Sulfur is right there, number 6. So 6 valence shell electron minus lone pair, none. Half of how many bonds? You have 4 bonds, so 8 electrons. So 6 minus 4 is 2. So plus 2 is their 4 more charges. Okay, so once again, I think that I give you the useful tip. This is a 4 more charges of minus 1. This is a 4 more charges of 0. So does this one here. And one extra, and then something that what is called a halogen, right? So this is a quite useful. Halogen was formed a bond with solid lone pairs, and the next is fluorine, chlorine, bromine. So this is useful. One last comment is the compound that's shown up here. Okay, so this one we showed up and show that minus 1 halogen. Halogens are happy. They are has a complete octet roles, and so it's all set. They don't want to change anything. But if you look at this one is a 4 more charges of 2 in the middle, and then 4 more charges 1 on each oxygen. So what is going to happen is this resonance structure is going to change by shifting the electron. These 2 electron, lone pair electron, to be used to form another bond. So therefore, you will have S double bond with those electrons, and this one stays the same. And so by doing so, no 4 more charges, nothing, even inside of nothing. So this is 4 more charges going back and forth. The resonance structure going back and forth. Let me get rid of all the 4 more charges. So no 4 more charges or whatsoever. The only, I guess, quote unquote penalty that you are hearing is this one is essentially 10 electrons, and this is a extended, or sometimes called expanded, octet rule. Right. This one is, there's something good thing about this is 8 electrons. It's actually not 10, actually 1, 2, 3, 4, 4. Oh, this is actually 12. So 12, they can take it. Okay, 12, they can take it. And then, like we discussed before, these are the one, the second law, second row. The other one must obey the octet rule, but anything about third and fourth and so on, they don't have to obey the octet rule. They can have an exception to the octet rule. Octet rule, and they can have more than 8. So this is actually more stable resonance structures. Thank you for your attention.